Hello, welcome to another Research Methods for the Biosciences screencast for Minitab. This screencast covers Section 10.6, Introduction to Parametric ANOVA, including Section 10.7, One-Way Parametric ANOVA with Equal Numbers of Replicates, Section 10.8, Tukey's Test, and Section 10.9, One-Way Parametric ANOVA with Unequal Replicates. This test asks if three or more independent data samples can be considered to be from a common statistical population. A significant result indicates that this is unlikely and that there are significant differences between two or more of the samples. For example, Table 10.7 gives the fresh weight of the lobelia variety Hannah grown in one of 4 types of compost 8 weeks post-weaning from a tissue culture environment. The question is whether any of the compost promotes superior growth of the plants. There are 2 common parametric one-way ANOVA tests implemented by programs, and which one you will use depends on whether the variances are similar or not. We can test if the variances are similar, also termed homogeneous, by doing an F-test first on the data using the program. See Chapter 10 in the book and Box 10.7 for further details. One of the main reasons why your data may not have homogeneous variances is if you have unequal replicates. That is, unlike the data in Table 10.7, your samples have different number of data points. In general, when using these programs, do not worry about whether your replicates are equal or not. Focus instead on using the correct test for whether the variances are similar or different, as the program will use the correct statistical test for unequal sample sizes if required. If you get a significant result from the ANOVA, you may then wish to work out which samples are significantly different from each other. We cannot simply do a t-test for each sample pair combination, as this increases the likelihood of type 1 errors. Instead, there are many other tests collectively called post-hoc tests that can be carried out. In many cases, we prefer to use a test called the Tukey's test, although other tests, such as the Games Hull test, will be suggested in this screencast if required. So let's do the test. I have already entered the data from Table 10.7 into Minitab. The first thing we need to do is to test whether our variances are homogeneous or not. We do that by tracking up to Stat and click, down to ANOVA, and then track down to Test for Equal Variances in the submenu that appears. We can see from the top right-hand box that Minitab is expecting response data that is in one column for all factor levels. This is how our data is set up. So I'm going to click in the response box, select plant weight, and press the select button to enter that variable. It now requires the factor. It's already put the cursor in the factor box. I'm going to select C2 compost and click the select button to enter it. I can press the options button here. You see, it gives me the option to use tests based on a normal distribution. And if you know that your data is normally distributed, you can click this button to do a more accurate test. I'm going to leave it unselected. So, let's press OK. Minitab does 2 tests for us, the multiple comparisons test and the Levine test. In general, although not perfect, as a rule, we can base our conclusion on the test that gives us the lowest p-value. See the Minitab help for more details. In this case, it is the multiple comparisons test, giving us a p-value of 0.286. So what is the meaning of the p-value? A p-value of 1 means we can accept the null hypothesis as true, whereas a p-value of 0 means we can accept the null hypothesis as untrue. As we travel from a p-value of 1 to 0, the transition point between true and untrue is set at 0.05 in the biological sciences. The smaller the p-value below 0.05, the more confident we can be in rejecting the null hypothesis. A value of 0.286 is above our transition value of 0.05, which means the result is not significant, and that we cannot reject the null hypothesis that states that there is no difference between the variances of our samples. So in this case, we will use the results from the ANOVA test that assumes equal variances, followed by the Tukey post-hoc test. And we do this as follows. We track up to Stat and click, down to ANOVA, and across to One-Way ANOVA in the sub-menu that appears and click. Again, we can see in the top right-hand box, Minitab is expecting the response data to be in one column, which is how we have formatted our data. So I'm going to select the response box, select plant weight, and enter it into the box using the select button. The factor box is already selected. It is C2 compost, which is the variable I need. And again, I'm going to enter it using the select button. If I now go over to the options button, it gives me the ability to tick an assume equal variances box. This is what we want, having done the test to see if our variances are homogeneous. I now press OK. I now need to tell it which post hoc test we want to do. I'm going to press the Comparisons button and I'm going to select 2 key. I now press OK and finally OK a second time. There are various results produced in the session window. The ANOVA result is given under Analysis of Variance and has given us a p-value of 0.003. This is below our 0.05 transition probability, and we can say there is a significant difference between our composts and can reject the null hypothesis. In fact, the difference is below 0.01, so we can conclude that there is a highly significant difference between the mean fresh weight of Lobelia variety Hannah when weaned on 4 different composts. But this does not tell us specifically which composts outperform which other. For this we need to look at the results from the 2 keys test. So if I scroll down, in this case, Minitab has formatted the 2 key results by placing them into a group. Each group is given a letter, in this case either A or B. Composts that are not significantly different from each other will contain the same letter. So we can see that compost A and compost C are both in group A. They are not significantly different from each other, whereas compost C, D and B are in group B, again suggesting they are not significantly different from each other. But compost A is in a different group to compost D and B, suggesting there is a significant difference between compost A and these other 2 composts. So how would we do the test if our variances were not homogeneous? In this case we would truck up to Stat and click down to ANOVA and click one way on the submenu that appears. We would go down to Options, untick in this case the assumed equal variances, OK. Because we're assuming unequal variances, we would need a different pairwise comparison post hoc test. If we click the Comparisons button, you can see that it only gives us one choice, the Games Hell test. This is a good test to use. Again, we would click OK, followed by OK to run the test. The output is identical in format to the test we ran for homologous variances. I hope you found this screencast helpful. For further information on how to use this test, or the theory behind it, then please consult the book. More information on how to use the program to perform the test can be found in our online web guides located in the Resource Centre. Thank you for listening.